Okay, let's jump in with geometry. This is the file for the free lesson and training staff. If you felt like last video was too slow, I agree. I'm going to be going a little bit faster. All right, so you should have this done and then just watch this quickly. Hopefully I fly through. A parallelogram must be a square. What that basically means is some of these are true only of squares. And not parallelograms, so not standard parallelograms. So diagonals of perpendicular is actually true of a rhombus. We say it's like a kite because it's a little pointed and it's perpendiculars. Opposite sides of congruence true of any parallelogram. Opposite sides parallels true of any parallelogram. A square is a special type where the diagonals are congruent, which kind of makes sense. If you saw a square, right, well, it makes sense that the distance in a square would be equal to one another. Okay, let's continue to the next question. They tell us that AF equals DF, and that angle F, and they mean this angle F here, equals 55, because then they ask us for this angle. Now, there's a basic rule: parallel lines cut by a transversal, parallel lines cut by a transversal. The Z angles, or the alternate interior angles, or Z shape, are equal. Well, that's the situation here, even though it could be a little bit harder to see. You have these lines here cut by this transversal, and if you actually see, there's a Z right here. So that angle becomes, angle D becomes 55. Now, in a isosceles triangle, two equal sides, the base angles, it's called the base angle theorem, they're equal. And if those two angles are equal, 55 plus 55 is 110, the final angle is equal to 70. Okay, so you have to put together a few different things that you know there. All right, lines. Now, in order to find the equation of a line, you need to find two things. This is the simplest way to teach this. You need to find the slope, the m, and the b, because the formula is y equals mx plus b. Now, to find the slope, what you do is you do y2 minus y1, right? In this case, they give you y2 minus y1 over x2 minus x1. Now, these points that they give you are on this line. Now, what we're looking to do is make a different line that's perpendicular to mn and runs through this point. So we're going to have to find the slope of this line and then do the negative reciprocal of that, right? So negative 5 minus 1 is negative 6. 3 minus minus 6 is 9. The slope's negative 6 over 9. Our slope, therefore, is 9 over 6, or 3 over 2, the negative reciprocal of that. Flip and negate. Now, to find the b, you plug into your formula. You now have the m, and you have a point on the line. The point on the line you have to plug in. So now you have that 1 equals 6 times 3 over 2 plus b, 8, that'll become 9, minus 9, it'll be negative 8, b will be negative 8, the equation will be y equals 3 over 2x minus 8. If you actually look at the choices, it says positive 8, so that's a mistake, actually, and the correct answer is minus 8, right? So that's important, this answer here, but it's minus 8, all right? And some students might not have gotten the y-intercept once you saw that the slope is only 1. All right, similar triangles, very important topic. I don't know if this is a pretty hard one to start with, but this is a basic shape of a similar triangle that we know, where you have a situation where you have z angles, right? Because these two lines are parallel, and you'll know that this angle is equal to that angle, and this angle is equal to this angle. Now, when you set up a similar triangle, you need to know that the sides are in proportion, but they're in proportion with the angle that they're opposite. So because that angle is equal to that angle, this side is equal to that side. And then you have this angle here equal to this angle. Now, they actually don't ask us for BC, they ask for BP, but we're only able to find BC, and then we'll have to go back and do Pythagorean theorem, and that's why we put that hint there, because some students will think that this will find them this. This is equal to this, but it actually goes by the angle opposite the angle. Okay, so I don't know if that made so much sense to you, but it should. So 4 is to 5 as 10 is to x, and there's a lot of different ones you could have done. You could have done 5 is to x as 4 is to 10, but you cross multiply 4x, 50 divided by 4, 50 over 4. That'll get you this angle here. So 50 over 4 will be 12 and change. That's right. And then you're going to have to use that one to find the hypotenuse. That'll be bigger. So the answer is going to end up being 16, right? Because that's the hypotenuse. But okay. And the way I knew a hypotenuse is that when a tangent intersects with the diameter, that's actually a right angle. That's a rule of a circle that they should know. They may not, but they should know that. Okay, this is another similar triangle situation. So let's look at it. It says, which measurements are justified by this similarity? So the rule here is that they should be in proportion. Again, similar to how we saw it last time. So let's see if we're able to figure this one out. So you have option 1, DE is 4 is to 6 as 4 is to 12. What you should just do on these is 4 divided by 6 equals 4 over 12. Question mark, doesn't work. 3 over 9 is equal to 5 over 15. Yeah, that does work. So 3, 9, 5, and a C is 15. That's actually right. This is to that as this is to the whole thing. All right, so you just divide. It's pretty simple to do that. Similar triangle. Similar triangle is a big, big topic, but you can see it's going to keep coming up. So if you weren't sure how to do it, this is similar to that shape we just saw, where this one's equal to this one. They tell you it's parallel, right? So it's parallel cut by a transversal. Similar situation. This one's equal to this one, and yeah. Given triangle similar. Which equation is true? A equals E. No, we're talking about angles here. A equals D. Angle AD. No. A equals plus B, C equals A plus B. No, A equals B. So that's really a hammer and comb on that point that we made in the other question. So take them to that one if they need. This is a mess. Hopefully it works out though. Okay, now the next one. They want to know what is the length of AB to the nearest yard. Okay, so let's see how we do. This is again similar triangle. You would do 120 over 230 equals X over the whole thing. Very important. Over the whole thing, right? Because it's a piece of the triangle and the whole triangle. So 230 plus 85 is going to be 315. Cross multiply and solve. Cross multiply and solve. Next one. Again, this is going to be basic similar triangles. So they tell you they're drawn below. RS is 5. ST is 7, XY is 10, YZ is 12. Now they tell you angle S and angle Y, angle S with angle Y. So that tells me that this side that I don't know, which basically what that tells me is then angle X with angle R. So now you could see you'd have to flip it. So the 12 goes with the 7. So the rule would be maybe 7 over 5 equals 12 over 10. Cross multiply. And then, is this equal? No, it's not. So no, they're not. They're not similar, because if they were, the sides would be in proportion. Okay, distance formula. The distance formula is a formula that you should know by heart. The formula is very simple. It's x2 minus x1 squared plus y2 minus y1 squared square root. All right, and you just got to do it again and again here. You want to find the perimeter, so draw out your thing, plot your points, and then you'd have to find each side. But it's a good opportunity to make them do this, because people are always careless on this topic. Always careless on this topic. Okay, again here they want to know what's the difference between DC and BE. So you got to find DC, find EB using the distance formula. Some of them will want to do other stuff, distance formula, and then subtract. Coordinate proofs. This is a pretty hard proof here, a pretty hard coordinate proof. So they tell you B is -3, -1. Always, oh sorry, -3, -1. I do that often. I actually did that when I was preparing it also. -3, -1, and you should always label B. And then -1, -4, -1, 1, 2, 3, 4. This is C. And they tell you that it's x comma 3, which means y equals 3. What does the line y equals 3 actually look like? It's this line up here. So the point will be somewhere on here. And they want you to create a triangle, right? So that hits this, the point will be on this line. It's probably going to be somewhere like here, you understand? Now, how would you figure out where this line is? You'd have to figure out the slope. So what is the slope? It's rise over 1, 1, 2, 3, 1, 2. So it's negative 3 over 2. Now, to make it a right triangle, well, they say an equilateral triangle. An equilateral triangle, not a right triangle. I'm sorry. Okay, so now we want to make this an equilateral triangle. So you would figure out the distance of this triangle. Nah, there's no way to figure out how to make this an equilateral triangle. So I'm going to change it to a right triangle. Okay, so a right triangle. That's the question that it originally was. So now the slope of this was negative 3 over 2. The perpendicular one's going to have a slope of 2 over 3. So you just draw it out. Rise, 1, 2, run, 1, 2, 3. Rise, 1, 2, run, 1, 2, 3. It's right here. The point 1, 2, 3, 1, 2, 3. The point 3, comma 3. All right, so I'll change that question by the time you get it, hopefully. Line ratio. Okay, this is a weird question you've never seen before. I'm going to teach you how to do it. Very simple. This is the easiest way. They want to divide the line into a 1-to-2 ratio. So this is the steps that I like to take. Okay, I make a chart X and Y. Step 1. I do y2 minus y1, that gives me 20, and x2 minus x1, that gives me 30. Then I divide this by this total number of pieces. So you're splitting it into 3 pieces, so I like to divide it by 3. Okay, you add 1 plus 2, and you say, this is a system, very basic. And what I get then is 10, and this is a mess. It shouldn't have worked out like this. Let's just, yeah, okay, so now it's going to look nasty, so I'm going to change this. I'll change this to 29. I should keep notes somewhere, otherwise I'm not going to remember. Question 13, all right, and I think 12 also had to change. 12, okay. So I divide it, so assume that this is going to be 21, all right? So then I divide it, and I get 7 over here. So then what you do is you go to your original point and add this on. So let's add it 1 time and see what we get. So after adding it on 1 time, we get 13 and 10. Now, since the first number is 1, that's all that we do. Since the first number is 1, that's all what we do. This is the final answer, all right? It's a little bit weird, but if you think about it, it'll make sense. This is just the system. So again, y2 minus y1, divide by the number of pieces, add it on the number of times that the first number says. Okay, and if just to show you, if we added it again, we would get to 23 and 17, and if we added it a third time, we would get to 33 and 24, which is not at all the points that we had. So I made a mistake. What did I do? I should have added this to the first point. I didn't add it to the first point, damn. The first point is the point 2, 8. So when you add 10 to it, ugh, a nightmare. When you add 10 to it, you're adding it to the first point, not to this number here, to the first point. So 10 plus 2 is 12, 7 plus 8 is 15, then you do 22 and 22, and then you do it one more time and you get 32 and 29. That's actually the numbers that we had. Okay, so all right, sorry about that. Equation of a circle. In order to do this, you need to do completing the square. I just taught you how to do completing the square actually for algebra, but quick review, you would divide 4 by, we're looking to get the equation of a circle into a special way, so watch what will happen. Divide 4 and square it, so you get x squared plus 4x plus 4, and you also add 4 to this side. You should also add that 12 over to the other side, so now you're at 12 and 4 is 16, okay? And then this will factor to x plus 2 squared, and then this inner term, it's going to be y squared minus 6y divided by 2 would be 3 squared plus 9, and you'd have to add 9 to this side also. So then when you factor this, you'd have y minus 3 squared, and then you could, now that you have x plus 2 squared plus y minus 3 squared equals 9, that's actually the formula of a circle. The coordinates would then be negative 2 comma 3. Negative 2 comma 3, okay, choice 2. Now, a shortcut to do this, okay, a shortcut to do this is just to look at This coordinate divided by 2 and change the sign, -2. This one divided by 2, change the sign, 3. Okay, that'll save you the work of having to do completing the square. Okay. Next one. This is a tough question, tough circle question right now. Okay. They tell you that this is 6. FH equals OG, and OG is also a radius. So if this is 6, then this is 6, and this is also a radius, this is 6. Okay. Then all of these angles are equal to 60 degrees. And they want to know angle GOH. So if this is 60, then that's 120, and it is solved. Okay, that's a little bit challenging. You'll see it again now. No, this one you won't. The rule is BCD. It's equal to 180 minus the one that's opposite it. I don't know. That's just the rule. So the answer is 70. Choice 1. This one here says which angle is not a right angle. So angle BCD is a right angle. The reason is because the arc that it cuts is equal to 180. It's a diameter. So then that angle becomes a right angle. Okay. Angle BED, that also, okay, angle BED, this angle here, also cuts the circle by a diameter. This is equal to 180, and a central angle is equal to half of the arc that it cuts. Okay, angle BDE, that one just cuts the circle into this piece here. This is not a 180 degree slice, so that's the answer. And angle FBD, that's a tangent hitting a diameter. That also is a right angle. Okay, so that's the answer there. If you didn't get that, I'm going fast, I know, but I think it's better fast than slow. Slow is boring. AF. Okay, now they want to know the area of shaded sector. Oh, they tell you the area is 2 pi. They tell you NL is 6. NL is 6. So that means the radius is 3. What's angle N? So now, this is the rule. We have the area of a small piece. So the rule is area of a part over area of the whole equals angle over 360. Okay, and we could find the area of the whole, right? So what's the area of the whole? It's pi r squared, 9 pi. So 2 pi over 9 pi equals x over 360. Okay, so you just got to cross multiply and solve that out. All right, that's area of the piece is in proportion to area of the whole thing in the same proportion that the angle is into 360, which makes sense. Okay, so that's that. Constructions. So I don't know if they're going to have compasses. This is a basic one. It's a perpendicular bisector. You take the needle point and you put it here. You set your arc at bigger than half, and you make a big arc. Then you put your needle point here, the needle, and then with your pen you do that, and then you connect the dots, and that'll be a perpendicular bisector. Okay, I don't know if they're going to even have compasses, so I don't want to spend a lot of time on it. Trig. The basic way to understand this is cosine x is just to memorize it. Sine 90 minus x. The reason, if you look at it, cosine x, adjacent over hypotenuse, over hypotenuse, right? Now, this is 90. So what's another fancy way we could call this angle? It's actually 90 minus x. Like, take an example. If this was 30 and this was 90, so then 90, this would actually be 50. It would be 90 minus that. 60. Okay, so the fancy way to call this angle is 90 minus x. So if you go to angle 90 minus x and you do sine from there, which is so opposite over hypotenuse, you would also get x over h. So this one you get x over h, and that one you get x over h. So that's the reason. That's the way to explain it in the event that you wanted to understand it a little bit more. This one is just basic trig. They want to know how far it travels from D to C. So it's tan 16 equals x TOA, opposite over, opposite over adjacent, opposite. Sorry, I made a mistake. So TOA, opposite 125 over adjacent. Then you would do it for the big thing, and then you would subtract it to find that piece there. Okay, so do that on your own. You should be able to do that. Transformations, massive topic. Clockwise would be in this direction. So this is, so it would be 90, 180, 270. All right, so that's that one. 21. A triangle is dilated by a scale factor of 3, so that would just mean the triangle grew by 3 times each side. So the slope is actually unchanged, right? The slope would be the same, so that is true. And we'll see it again in a second. Perimeter is different, the area is different. The angles are actually the same, so that's also not right. The honking is so irritating. Could you please stop honking? We are live right now. We are live. This is a 3-dimensional rotation. It's like, imagine this was a flagpole and this thing whirled around in a circle. So you'd have a circular base and it would be a cone. All right, just try to picture it. I wish I had a video where I could show you. This one says, bottom line, they say that A, this, it's just a similar triangle case. Okay, so DE parallel to BC. That's right, actually. AB equals BD is not true. AD equals D parallel, that's not necessarily true. So it's just the parallel thing. There's similar triangles in that situation. So which one will not be congruent? Always the answer is a dilation. It's growing it. This one, the transformations that happened was it was reflected. Reflected 1. The way I do reflected 1, 2, 3, 4, 1, 2, 3, 4, and that'll work for every point. 1, 2, over the mirror, over the image, so over the x-axis, and then this here, from here to here, looks like it had to be rotated, right? So the perimeter is larger. No, it doesn't change. The only thing that changes it is a dilation. So the translation was performed? No. I mean, no, because if this slid down, the D wouldn't be flipped. And the area is equal to the original. Yeah, it's unchanged, the shapes. It's very similar. It maintains its isometry. It's a rigid motion, they call it, a rigid motion. Okay, this one here, they, where did we just, oh, there you go. This one here, so they rotated at 180. They just rotated at 180 degrees. So 11 is to 5.5. It's just times 2. That one's with that one, right? So that shouldn't be so hard. Basic rotation. This one, they want to know does not carry the square onto itself. So let's look at the ones that do. For x equals y equals x, that's this graph. So if you reflected it, this triangle here would land on the other triangle. You understand? It would be onto itself. It wouldn't occupy any new territory. Let's look at another example. The line y equals 2, that's this line. It cuts it in half, you understand? So when it reflected, and then the other one, x plus y equals 4, it's y equals 4 minus x, which means that it actually has an intercept of 4 and a slope of -1. I don't know if they're going to be able to see that. That's very hard. So at least if it's a 50-50, you know, x equals 0 is this line. No, it would reflect. This point would reflect onto there. There would be no, it would occupy new territory. What transformation was used here? So I think A, B, C, X, Y, Z, so C and Z are the same. And so this one, 1, 2, and then 1, 2. So that's reflection, you understand? It was reflected to here, here, and here, and then after that, and this would be, this was A, and this was C, and after that, C went on to Z, A went on to X, and B went on to, I'm sorry, I drew this wrong. It would be this triangle, not this, whatever, okay. This one was translated and then reflected. Which one would make it unequal? A dilation. Dilation of lines. Okay, here's another very simple thing. The questions you ask yourself is, first of all, they give you two things, a scale factor and a point centered on. Is this point on the line, okay? So you plug in 7 for y, 2 for x, and you get 7 equals 8 minus 1. 7 equals 4 times 2 minus 1. 7 equals 7. If the point is on the line, which in this case it is, then the formula is unchanged. Unchanged. The answer is choice 3. Now let's say it wasn't on the line, then you would just take 2 and multiply it by the intercept, and it would be negative 2. So this one would be the answer if it was not on the line, but this is actually the answer. Prove that triangle BDC, it's this big triangle here, is congruent to triangle ABD. It's not hard proof. You have this one reflexive. You have this angle, opposite angles in a parallelogram. I think that it's stated that it's a parallelogram. If not, then it wouldn't be possible. And then this angle here, and this one's alternate interior, so now you have angle, side, angle, or we had side, angle, that works also. I guess if it's, there's other ways to do it. You know that these sides are equal. It should be basic. It should be pretty simple. I could have made this a little harder. This one here, prove that triangle BCE, this triangle here is congruent to this triangle here. So you have CE equals CF, so that's 1 already. That's helpful. This angle here is reflexive, and then the parallelogram, no, so. Oh, and then they tell you that all these angles here. So you have this guy. So you have again angle, side, angle, side, angle, and this one angle, side, angle. Yield. Volume comes up pretty frequently. We'll need the reference table for this one. We'll need the reference table. Pull it over. So the Death Star is a sphere, so we're looking for the formula of a sphere, 4/3 pi r cubed. 4/3 pi r cubed. And then they tell you the volume, so you plug this in. Then you solve. Whatever you have to do, you do. The next one, a cylindrical container, cylinder, okay, pi r squared h. It's filled with water and has a diameter of 10 inches, so 5, and a height 8. If the water weighs, what is the container? So now what you have to do is you get this number, and then you multiply it by the pounds per cubic inch. So it'll give you cubic inch times pounds, and they always add that extra step. Always. Look at this next one here. Is a die has a length of this. So again, a die is a cube. It's 2 times its side cubed, right? That's 8. And then determine the density. So density is mass over volume. So mass 40.2 over volume. Mass. Okay. I don't know if that's on the reference table. Density. Okay. This guy here, the diameter of the cone is 16, so 8, radius equals 8, the height is 40, what is the volume? So it's 1/3 pi 8 squared, h, 6 times 40, and then what percentage is it compared to the volume of the apparatus? Well, the apparatus's formula is pi 8 squared times 40, no 1/3, so it's 33%. And then the last part of this question is if the apparatus weighs this, what is the weight per? So it's weight over. So you do 350 over, I think it wants of the apparatus. So it's over this one here, 350 over that. All right. And then the last, are we at the last one? Yeah. This is a basic. You take the square. You have a circle, it's inscribed in a circle. Now, the rule is that the diagonal of the square, okay, that the diagonal of the square is equal to the diameter. So now they tell me the diameter is 6. This is a square, so it's x and x. It's x squared plus x squared equals 6 squared. 2x squared equals 36 divided by 2 divided by 2. X squared equals 18. Fine, and then square root of both sides, and you'll get 4.2 something. And that's it. I think that was quicker. I think everyone's prepared, so let me know if you have any questions.